Hey guys, welcome to the new video, and in this video we are going to discuss about distributed tracing. So without any further ado, let's jump into the presentation. So let's discuss about the OpenTelemetry. So OpenTelemetry is a project that is a fusion of open tracing and open consensus. And OpenTelemetry defines some standard specification and convention for how the data should be transmitted from between the various components. OpenTelemetry provides a set of APIs and client SDKs which you can use to instrument your application and send those traces. OpenTelemetry uses OTLP protocol, which is specially designed for dealing with traces. And OpenTelemetry has one component which is called collector, and this collector is responsible for collecting the traces from different applications. These could be your database applications or your microservices written in Node, JS, or Golang, or Java. So now let's discuss what is OpenTelemetry collector. So by definition, OpenTelemetry collector is a vendor agnostic way by which you can receive, process, and export the telemetry data. And this is a vendor agnostic approach. So you can use any vendor platform, or you can use some open source tool like Zipkin or Jaeger to visualize those traces. But OpenTelemetry makes it vendor agnostic. OpenTelemetry collector is comprised of three major components, which is receiver, processor, and exporters. And these all three work in a combination to set up a pipeline. So let's see what a pipeline looks like. So this is a high level overview of what a pipeline looks like. So we have receivers, which either can be a pull based or a push based receiver, which can receive or extract the data from some sources. Then the data moves to the processor where some sampling or some transformation happens, and then the data is sent to the exporters, and exporters essentially export the data to some different destinations. So receivers could be anything like, yeah, we can have Jaeger as receiver, then we can have Prometheus, Zipkin, or OTLP endpoints which are a receiver, and then we can have some processor like some of them are like sampling processor or some changing attributes. You want to manipulate some attributes, you want to add some attributes. Then we have batching as well, which means that you can batch the data, and in a single batch you can send the data. And after that we have exporters. So exporters are basically some platforms where you can essentially visualize the data, and some of the major exporters are Jaeger, Zipkin, or Prometheus, or it could be OTLP platforms or some vendor platforms like New Relic or Dynatrace. So now let's look the architecture, like what we are going to do in today's video. So this is an architecture diagram, and this is following the Daemon Set pattern. So let me explain you the architecture of this deployment that we are going to do today. So we will be having our application. So I'm going to have two applications. One is a Node.js application and second one is a Java application, and they both are instrumented. So essentially our applications are capable of collecting those logs and sending those logs to the defined OpenTelemetry collector. And since this is a Daemon Set approach, Daemon Set pattern, so we will have uh, uh, the collector, OpenTelemetry collector, present in all the nodes. So in the diagram as well, you can see that I have OTel collector that is present in all the nodes, and essentially our applications are going to send these traces to the respective daemon set or respective instance of the daemon set. And after that we will have another OpenTelemetry collector that is receiving the data from all these daemon sets. And essentially we have Jaeger as well. So we have the Jaeger UI, which is going to consume the data from this OpenTelemetry deployment. So essentially we will be going to have 4 instances of the OpenTelemetry collector. 3 instances will be for each node, and one is going to be a deployment which receives the data from all these OpenTelemetry collectors. So let me open my terminal here. So here I have already one running Kubernetes cluster, and if I do kubectl get nodes, I should see my cluster here. So let me open the directory here as well, just to showcase you the folder structure and the code here. So here you can see I have two folders. First one is the service A and the second one is the service B. So service A is essentially a Node.js service, and if I show you the app.js file, this is a simple Express.js application, and this has three endpoints. The first one is the hello, then I have the random endpoint, which is just fetching some random facts from the internet, and then I have one call endpoint, which is calling the service B using the fetch API. After that, this is the tracing.js file. So this is essentially doing the automatic instrumentation for us, and here we are passing some environment variables, essentially the endpoints and the service name as well. So these are the two things that this service need. Then second service is the Java service. So service B, if I show you, this is a Spring Boot application, and if I go to the SRC, I have only one controller here, and inside that I have only one function, which is a get mapping, and which just simply returns you the hello world string. And essentially our Node.js service is going to call this Java service using that call endpoint, and then it is going to return this hello world. Let me show you the Docker file for this as well, because this Docker file is a bit special. And why this is special? Because we are using the OpenTelemetry agent here, and then we are running that along with this OpenTelemetry agent. So you can see here, this is the statement, this is the command which is running the OpenTelemetry agent along with our app.jar. And in the Node.js application, we don't need such thing. So if I just simply show you the Docker file, here you can see this is a simple Node.js application. Let me collapse this all. So now if I show you a couple of other files as well. So if we go to the DS pattern, so this is a Daemon Set Pattern that we are going to follow, and here we have this Daemon Set collector. So essentially this is going to be deployed on all the nodes. And if you see this section here, which we talked in the OpenTelemetry collector part, we have receivers, we have processors, and then we have the exporters as well. And then these are the pipelines that is formed using these components like the receiver, the processor, and the exporter. And then we have this OpenTelemetry collector, which is essentially a deployment, and this is going to deploy as a deployment. And if you see here the exporter section, so I am essentially going to forward all my traces to two sources. So first is this this is the endpoint of New Relic, so I am using the New Relic as a platform, and the second one is for the Jaeger. So I am also using Jaeger as my visualization just to get the distribution tracing insights. And here I have to pass the API key, so that I'll show you in couple of minutes. And to start with, like I just want to show you one more thing. So if you take a look on this this Daemon Set collector, so here you can see that we are passing the endpoint as this one, and this is nothing, this is the endpoint of our OpenTelemetry collector. So this one, which is running as a deployment. So let me quickly install the OpenTelemetry operator, because these resources are going to be created by the OpenTelemetry operator. And let me quickly install the Elasticsearch as well, because I'm going to use the Jaeger. And for the Jaeger, I'm going to use the production based approach, which provides you two options as a storage. So first one is the Elasticsearch, and second one you can use Cassandra as your storage. So let me show you that as well. So this is the Jaeger file, which is essentially going to install the Jaeger. And if you see here, so I'm going to use the strategist production, and then the type as Elasticsearch. You can use Cassandra as well, and then you have to give your Elasticsearch URL, so that Jaeger is going to store those traces, those insights into the Elasticsearch. So let me quickly install the Elasticsearch here as well. Let me do helm install. So this is going to install only one instance of Elasticsearch. Oh, installation failed. Let me try again. Yeah, so Elasticsearch got installed. If I do get pods, we should see Elasticsearch pod that is in creation phase. Meanwhile, what we can do is we can install the OpenTelemetry operator and Jaeger operator as well. So let me first install this OpenTelemetry operator, which is this one. And one more thing, I just forgot to mention you that when we are installing the OpenTelemetry operator, we also need the cert manager, because OpenTelemetry operator uses that cert manager in order to issue some certificates. So let me quickly install the cert manager. So this is going to install the cert manager, and after that we can install the OpenTelemetry operator. Yeah, so it got installed. Let me now install the OpenTelemetry operator. So it got installed successfully, and if I show you get namespaces, so essentially it creates one namespace as well, which is this one, OpenTelemetry operator namespace. If I show you the pods here as well, so we can see we have the OpenTelemetry pod that is up and running. Now let's install the Jaeger here. So first we have to install the Jaeger operator. Okay, I need to create the namespace as well. So let me create then observability namespace. Now I can simply install the Jaeger operator. Yeah, it got installed successfully, and now I can install the Jaeger. Yeah, so our Jaeger got installed. Jaeger also got created successfully. Let me show you the lens ID so that you can get an insight like what pods do we have. So if I go to workloads in the pod section, this is our Elasticsearch, which is up and running. Then we have observability namespace. Here our Jaeger instances are getting created. So we have the Jaeger operator, we have the collector, and then we have the query. So essentially this is the UI part from where we can visualize the traces. After that, if I show you the observability namespace as well, so again we have just operator here. We have to install the OpenTelemetry collector just to collect those traces. We are done with the basic setup part. Now we can set up the our OpenTelemetry collector and OpenTelemetry daemon set as well. And finally, we can install the application. So let me go to this DS pattern folder, and here let me first install the deployment, uh, which is a deployment that is going to connect to our Jaeger. So let me apply this. So our collector got created. We can see this in the lens ID as well. So here you can see our collector is getting created. Yeah, so our collector is up and running. And one thing, so if I go to the services here in the network, in the services, you should see one open hotel collector service, this one, and this is the same service that we are using in the daemon set. So that daemon set is able to forward those traces to this instance of the OpenTelemetry collector. So if I show you the file again, this one, which is a daemon set OpenTelemetry collector daemon set, here you can see the mode as daemon set, and this is using the host network. So this is the section where we are specifying the endpoint of our OpenTelemetry collector deployment. So let me apply this daemon set as well. So this is going to essentially install one OpenTelemetry collector in all the three nodes. So we should see three instances of this OpenTelemetry collector. So if I go to pods, you can see we have three OpenTelemetry collector instance, and again these three are running on a different all the three different nodes. So because we have three nodes Kubernetes cluster, so that's why it is installed in all the three nodes. Now we can simply run our application, which is simple, that Node.js application that we saw, and this is again Java application that we saw. So here you can see we are passing the our endpoint as our daemon set endpoint. So this is pointing to the daemon set. So our essentially our applications are going to send those traces to the daemon set, and then daemon set is forwarding those traces to the OpenTelemetry collector. And here I have passing some attributes as well, like service name and all those things. these are the requirement of the service. And here you can see I am passing the service B endpoint. If you look at here, because if you remember, in the Node.js service, we are calling the Java service as a REST API call. Let me quickly apply this YAML file, and then we should be able to visualize those traces. So our application got created. Let's see them. So they are still in creation phase. One thing we forgot to do is that I told you that we are using the new Relic as one of the platform for visualizing those traces, but we forgot to put the API key there. So let me show you them as well. So this is the configuration where we are referring to New Relic platform. Let me open the dashboard of New Relic here as well. So this is the New Relic dashboard, and you can simply go and do a sign up here. And if you go to this API key section, there you should see your API keys, and if not, you can simply go and create a API key. So I have already created one API key with name tracing. So I'm going to simply copy the API key. Let me copy the API key, and I can simply go and put it here. And I can just simply apply this file again. So let me do that. Yeah, so it got configured successfully. And now let's do the port forwarding of our application, which is a Node.js application, and then we should hit some endpoints, and then we should go to the Jaeger dashboard, and we'll see those traces. So port forwarding is running now, and now I can go to the browser, and let me here run some endpoints. So the first endpoint that I'm going to run is hello, which should return me the hello world along with the timestamp. The second endpoint that I wish to run is random, which should return me the random facts. Yeah, so here you can see we got some random facts. And then third is the call endpoints, and this endpoint is going to call our Java microservice. So let's hit, and this should return us hello world. Yeah, so we have done the three API calls, and now let's go to the Jaeger UI, and let's see these traces in the dashboard. So essentially, let me split this terminal, and I will do the port forwarding for the Jaeger UI here. Let's open that UI here. Yeah, so here you can see, we can see our both the microservices, which was the Java app, and second one is the Node app. And if I just find the traces here, so we should see three traces because we did the three endpoints. But if you see here, so this is the last latest endpoint that we hit, and this was the call endpoint, and which was calling the Java microservice here as well. So if I expand this, so here you can see the entire graph here as well, the dependency graph. So you can see we have our Node app received the request, and then it forward that request to our Java application, and here you can see it called this controller.java function. So if you see here, you can see some bunch of details, and again if you expand the tags, so you can see some more details here as well. And you can also change the views here as well, so you can do the trace graph, and you should be able to see how your request is flowing between the various services. Then you can do some span table, so you will be seeing the data in the span in the table format. Then you have the trace JSON, which is going to give you the JSON format of the data. So you can see the trace ID and spans and tags here as well. Let me show you another this thing as well, another request that we made. So this was for, I think, for the random this was the random URL, random endpoint. And if we go to tags, so we should see that this request was made to this target, which was slash random.json, and this was the URL that was hit. and this was the endpoint which we actually called from our browser. So now let's move to the New Relic platform and see these traces there as well. So if I go to the New Relic, go to this New Relic homepage, and here you should see your OpenTelemetry service. So you can see we have our Node and Java service. So if I just open this Node service, we should see our those traces here as well. So here just go to this distributed tracing part, and you can see we have a request for Node app, and here you can see we have all the endpoints. So this was just a 4-minute ago request that we made, and this was again for that call that forwarded the request to the Java application. So you can see same thing here. Yeah, so this was pretty much it for this video. In the next video, what I'm planning to do is I have another approach for deploying this distributed tracing. In that video, I want to showcase you the different pattern, which is having the OpenTelemetry collector as a sidecar, not as a daemon set. And they both have a trade-off in itself. Like with daemon set approach, you cannot enable the multi-tenancy, but with sidecar pattern, you can enable the multi-tenancy. You can have the multi-tenancy because essentially the tenants are not going to see each other's data, but that has some impact on the resource consumption. So essentially, you will have multiple instances of those sidecars, those OpenTelemetry collector that are continuously running along with your application. So if you have any doubts or any queries, feel free to drop them into the comment box, and I will see you in the next one.